Right, let's go to example number 7. An object of mass 1.5 kilogram is suspended from a rough pulley of radius 20 centimeter. The pulley has a moment of inertia 0.02 kilogram meter squared about the axis of the pulley. The object is then released from rest and the pulley rotates without encountering any frictional force. Assuming that the string does not slip on the pulley, after 0.3 seconds, determine the linear acceleration of the object, angular acceleration of the pulley, the tension in the string, the linear velocity, and lastly the distance traveled by the object. Okay, so firstly we are going to start by drawing a free body diagram. So the first free body diagram that we are going to draw is for the pulley. Okay, so draw a circle. Okay. Right, so the forces that is experienced here is weight, and then S, which is the force, and then we have tension. Okay, lepas tu we draw now, we are gonna draw for the 1.5 kilogram block. Okay, so this one is just weight and then tension mg, and then S force. So this one is for the block, so mbg and then tension. Okay, so now we are going to create equation based on this free body diagram. So first let's look at the pulley. So total torque will be equal to moment of inertia times angular acceleration. Okay, so the torque is RT equal to I alpha, where alpha can also be written in terms of linear acceleration, which is this one. And then substitute dalam ni, we get A over R. So we get the tension to be equal to I A over R square. So this is first equation lah. And then let's look at the block pula. So total force is equal to MA. Well, before that, let me just draw the direction of angular acceleration and the linear acceleration. So this is the angular acceleration, and then this is the linear acceleration lah. A pula alpha A. Okay, right, lepas tu we then so mbg minus T equal to MBA. MB itu block lah, the mass of the block. Okay, so now this one is equation 2, so we can then substitute equation 1 into equation 2. Okay, so this is just mbg minus A over R square equal to MBA. Okay, so information that we have is given, so just substitute lah. 1.5 9.81 minus I is 0.02. A is the one we are looking for. R is 0.2 equal to 1.5 A. Okay, so rearrange this, you should get the acceleration to be equal to 7.36 meter per second square. Okay, And then question B, we can then find the angular acceleration by using the relationship between linear acceleration and angular acceleration, which is this formula. So you get A over R. So you should get the angular acceleration to be equal to 36.8 radian per second square. Okay. Right, so question C pula. From equation 1, we can get T, which is I A over R square. So you then get the tension to be equal to 3.68 Newton. Okay, and then question D, we can use the equation of linear motion, which is equal to VU plus AT. The check-up there starts from rest, so we know initial velocity is 0, plus dengan 7.36, which is our acceleration, and then the time is given, which is 0.3. We then get the velocity to be equal to 2.21 meter per second lah. Okay, so the direction is still downwards sebab acceleration dia pun turun bawah kan. Downwards. Okay, lepas tu final question, the distance traveled by the object in 0.3 seconds. We can then again use linear motion punya equation, AT square. So this is 0 plus half 36.3 square. We then get the distance traveled by the object in 0.3 seconds to be equal to 0.331 meter. Okay, so that is the solution for for example number 7.